Okay, so this is going to be a video about extrema, or extreme values. And the reason why we're going over this is because one of the main goals of calculus is describing graph behavior. So in this case, we're going to be describing extrema, or another word for it is minimum and maxima of a function. Okay, so minima and maxima mean extreme values, or another name for them is extrema. Just think the extreme high and the extreme low. That's why min and max represent the extreme values. Okay, to kind of go over more about extrema, I have 3 examples of graphs here. In this first one, it is on a closed interval. That's why it says closed interval here. That's what these brackets mean. It goes from A to B. It's not all real numbers. It's just X from A to B. And as you can see, it's continuous throughout. So because of that, this would represent the max, and this would represent the min. This would be called an endpoint extrema, or the endpoint min, because it's on the endpoint. But the main thing you have to know here is that that's the min, and that's the max. Okay, the second example right here is on an open interval, which means it's not exactly equal to at A and B, which means that at A, this value is never reaching A. It's getting closer and closer and closer to A, but never reaching it. So say A was -1, this would be negative 0.9999999, just getting infinitesimally closer to -1, but never reaching it. Same with over here. Say B was equal to 2, this might be equal to 1.9 or 1.999, but it's never actually getting 2. For the number 2, if B was equal to 2. So that's called an open interval. That's why it has parentheses versus the brackets. Now, this is not considered a min right here because that value doesn't actually exist. It's not included in the interval because it's not a closed interval. So there's no min here. Now you could say 1.9, but then you can get even closer, 1.999, if B was equal to 2. But it's never actually equal to 2, so you just say not a min. So anytime that it's an open interval, there's no min. Here, this is still the max because it doesn't represent a point where there's just an open circle. So this can still be the max, but for open intervals, you can't have those endpoint mins or maxes. Okay, and the last one right here, this one is a closed interval, just like this first one, only this time I put some discontinuity in the function right here. Okay, so before this was representing the max, but now it can't be a max because it's a hole. So this function would not have a max because that max value doesn't exist. Again, we can get infinitesimally closer to it, but it's never actually reaching a value, so there is no max for this function, just like there's no min for this one. There is still a min for this, however, because it's in a closed interval. So based on the fact that to have a min and a max, you need to be closed interval, like I have here, and it's got to be continuous throughout with no holes. There's a theorem that was created that's called the extreme value theorem, and it basically states as follows. If a function is continuous on a closed interval, just like this one, closed interval, then f has both a min and a max on that interval. So if it's closed and it's continuous, there's a min and a max. That's basically extreme value theorem, and it's based off these graphs that I just showed you right here. Okay. Now it is possible to have an open interval and be non-continuous and still have a min and a max. What this theorem is basically saying is that if it's continuous and it's closed interval, it has to have both. It has to have a min and a max. Okay, so that's a little video about extrema or extreme values. If you have any questions about anything I went over on this, let me know.